the material that is required to be placed inside the windscreen in order to protect that car is a white and shiny material, because we need to reflect a lot of heat as much as possible. Yeah, so basically that is exactly what we are supposed to respond in that particular question. And now we need to move to the next part of the question. Question 2 says, two metal spheres of different diameters are heated to 900 degrees Celsius. In hot oven, the two spheres are now removed from the oven. Yeah, explain at any difference in the initial rates of emission of radiation of thermal energy between the two spheres. Yeah, so we have two spheres of different diameters. So remember, the rate of emission of radiation will depend on the surface area. So if you have a sphere of a large surface area, if you have a sphere of a larger diameter, when a sphere has a larger diameter, it means it has a large surface area. So the rate of the rate of radiation in the larger sphere is going to be higher. So we are going to say that larger spheres have larger rates of thermal radiation, thermal radiation emission. So basically in this particular question, you are supposed to identify that if we have a large surface area, there will be a larger rate of emission. One hot sphere is now heated in a hotter oven. State and explain any effect on the rate of emission, thermal energy from the sphere when it's removed from the oven. When it's removed, yeah. So we can also say that we have the in part A, we need also to add a statement and say large spheres losses, can be able to say, yeah, let me just write this properly, losses thermal energy at a greater rate, State and explain the effect of the rate of emission. So as a greater, we can say this is greater rate of emission, greater rate of emission or of radiation, greater rate of radiation, the greater rate of radiation in this case. Now moving to question 3, whereby we're told the diagram shows a metal pan containing water being heated by an electric heater. Then we can see we have the heater down here, we have the pan. The pan is made of a good conductor, it's metallic, so it has to conduct heat. and then we have water, and the water is going to absorb the heat from the pan, and the water will heat will be transferred in liquids through convection. We shall look at that. Now complete the sentence to describe how thermal energy is transferred. Thermal energy is transferred from electrical heater to the bottom of the pan, to the bottom of the pan, because we are talking of a conductor, through conduction. Through conduction, because when we are talking of materials involved, a conductor involved, that is conduction. But if we are talking about the space between the pan, because there is a space, and also we have the coil or the heater, there is no material between, that there could be a space. So another student could talk of radiation, yeah, through radiation. So another student could say that at that point, and the two students, both of them are correct. Now the diagram shows then thermal energy transfers through the bottom of the metal pan. So that's question number 4, where we are going to say this. What? This is conduction. Conduction. We have the next question number 5. Remember, most of us, we usually use a thermos flask. We use thermos flask in our homes so that we can be able to keep the liquids, our coffee, our hot tea. We keep it a bit hot, or if you want to keep a liquid cold, you can just use a thermos flask. And we are supposed to suggest the material of the stopper. You can see the stopper is up here. This is the stopper that we are talking about here. And the material of the stopper here should be a poor conductor. And we can talk of maybe cork, we can talk of plastic, we can talk of rubber, any of that. So we can talk of plastic. In our homes, we have thermos flasks. Go and check what is the cork, the stopper, the stopper of that thermos flask made of. Yeah, so be careful you don't also break it for safety purposes. The diagram shows a cross-section inside a vacuum flask containing a cold liquid. The vacuum flask is being used to keep the liquid cool in a hot day. Explain how the labeled features of the vacuum keeps the liquid cool by reducing thermal energy transfer. Include the names of these processes that we are talking about. So, number 1, we shall look at we have a vacuum. A vacuum is one of the feature that is actually reducing different energy losses. Yeah, that is a vacuum prevent, or we can talk of the vacuum in a thermos flask prevent or reduces heat transfer through conduction and convection. So since inside the vacuum there is no material, we are going to reduce heat loss by a process called convection and conduction. Then you can also see here these surfaces are silvered. They are silvered. They are shiny. Yeah. So we can talk of silvery. We can talk of silvered surfaces. Silvered. We can write silvered surfaces. Which mode of heat transfer are they used to prevent? They are used because shiny and silvered surfaces, they are going to reflect the radiations. So this is going to prevent heat loss through it's not going to prevent heat loss through radiation. Yeah. So we can say this is going to reduce heat transfer by radiation, and shiny surfaces are poor absorbers of radiations. Now, if shiny surfaces are poor absorbers of radiation, it means the liquid is going to remain cold. It's the cool temperature of the liquid will be remain, because it will not be absorbing any of the thermal energy from the surrounding. So the liquid remain cool. Yeah. Another way, we have a stopper. We also have a stopper here, which reduces heat transfer or reduces heat gain, or it also reduces heat gain by convection. So that is exactly what we are supposed to do, and in order to earn the marks for that particular question. And if you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. In Proflan, we do maths, and physics, so it will be very important for you to be part of this team. Be part of us. Hello? Working. You're working. Yeah. Está working. Andiamo, tomerei. Abo bandi bari gukorega siamo baje. Ngi bajerde. Ngày sợ, ngày buổi. Now we need to proceed to, in this question number 7, we were told that the electrical heater is placed at the floor of the room in the house. The heater is switched on. If you are having a heater that is placed at the floor, that must be a convection heater. A radiation heater can be placed at the top, at the corner of the room, and then it can be able to spread the radiation throughout the room. But for convection heaters, they should be placed on the floor of the room, which is going to be, process is convection. 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 Convection, yeah, convection, not vection, convection. All right. Number 8, electrical heater is placed in the floor of the room and the heater is switched on. The power is 1.5 kilowatts. The air in the room has a mass of 65 kg. The specific capacity is 720. Calculate the time taken for this heater to raise the temperature. We know that thermal energy is usually MC change in liter. That is the formula we use to calculate thermal energy. Now, in this case, the heater that is the heat that is supplied by the heater is absorbed by the air in order to warm it up. So we can be able to see the mass of the air is 65 kilograms times the specific capacity. C is the specific capacity, which is 720. Then we have times the temperature change. Temperature change in liter is going to be 15 minus 8, which is going to be 7 degrees Celsius. So this is going to be 7 degrees Celsius at that point. So which means that for us to get this, we have to do the calculations. And the calculations, how do we go about it? We have to get a calculator coming with it. Later chukua mtoto nimaliza kwanza. Later I'll see you later. Yes, later. What? So we have to pull this, and this is going to be what? 0.65 times 720 times 7, which is going to translate to 32. That is 327,600 joules. So this is the energy that is being supplied. But also you need to remember that this question is not about energy, it's about time. But energy, electrical energy is usually power times time, isn't it? So we can be able to use this formula also in order to go about this, because the energy is this one, which we are going to replace at this particular point. So this is going to be 32,600 is equals to, the power is given here 1.5 kilo. Kilo in physics means 1,000, so times 1,000, then times time. Remember, we are looking for time in this particular question. We are looking for time, so meaning in order for us to get time, we are going to divide both sides by 1.5 times 1,000, 1.5 times 1,000. So that our time is going to be equals to this answer we have gotten here, divide by 1,500, and that is going to translate to 218. That's going to translate to 218 seconds. Tell me, bless you. Yeah, God. 18 seconds. So which can translate to 220 seconds. Yeah, approximately 220 seconds. That's how you are supposed to go about that. We have question B, part B of this question. Part B says, state 2 reasons why time calculated in A. The reason as to why. In part B, we are supposed to state the reason as to why the time calculated in A, this time that we have gotten here, is smaller than the actual time taken to raise the temperature of this. So what is it? Yeah, so because some of the energy is used to warm the walls of the house, of the room. Not all the energy is going to be used to warm the air. Some energy, yeah, will be used to warm the room. So not all the energy from the heater is absorbed by the air. Now, for that reason, the temperature or the energy absorbed by air is going to be less than the one that is supplied. So in that case, that time is not going to be, actually the time is going to be smaller. So we can also say some thermal energy is conducted, is lost to the surrounding, is conducted away through the walls. Yeah, so you can see here some energy is conducted through the walls, through the walls, all, yeah, through the walls, through the ceiling, yeah, through the walls, so some of the energy is going to be lost. Some of the energy is going to be lost. So the temperature change you are going to have will be a bit smaller. So next, follow me.